Well, like the previous problem, we're going to have to do quite a bit of work on these next couple where we're trying to find the distance between two parallel lines or between parallel lines. And we know that if two lines are parallel, they've got to be equidistant. The lines have to be equidistant from each other at any points of intersection between the two parallel lines. So let's see, find the distance between parallel lines R and S, whose equations are y equals negative 3x minus 5 and y equals negative 3x plus 6. So we know they're parallel. They've got the same slope. Let's just get an idea of what's happening here. We got an x and y axis, and you got one line that's got a y-intercept, say down here at negative 5, and you got another line that's got a y-intercept up here at positive 6, and we're trying to determine the distance between these two parallel lines. And specifically, I'm going to try to find it, let's say, right in through here. All right, now, one thing I need to do is find the one thing I need to do is find the slope for a line perpendicular, because if I can get a line that's perpendicular, then I can find the distance. Now, I don't really know any points, except that I can assume that I've got, if I use the y-intercept right here, I can use that as an endpoint for my equation for my perpendicular line, one endpoint for my perpendicular line. And so if x is equal to 0 in this equation right here, that y-intercept is negative 5. And so I can then assume that my line perpendicular, let's call it P, has got one endpoint of where x is 0 and y is negative 5. All right, and so if my slope then is the negative reciprocal of negative 3, then my slope is 1/3. So let's put this through point slope and get an equation for this line that is perpendicular to both of these parallel lines. All right, so there we got an endpoint slope. 1 minus negative 5, which that's going to become positive, equals 1/3 x minus 0. So we got y plus 5 equals 1/3 x. And 1/3 times 1/3 times 0 is just 0. Let's subtract 5 from both sides. And so our equation for our line that's perpendicular to both of these two lines is 1/3 x minus 5. Now, I want to put this through a system of equations because I need to find this point right here where this intersects. And once I do that, then I can take those two coordinates and solve it using the distance formula. So if I say that y equals this, we can solve for that point of intersection, and I'm going to substitute this for y. So now let's see what I've got. Hopefully I've got enough room before I move. So now I'm going to have 1/3 x minus 5 equals negative 3x plus 6. All right, well, let's add 3x to both sides and add 5 to both sides. And once we do, we got 1/3 x plus 3x equals 11. Hopefully you can see your way through that, what I did. And 3x is the same as 9 over 3x. And so when I add those together, I got 10 over 3x equals 11. And to solve for x, I'm going to divide by that 10/3, which is the same as multiplying by 3 over 10, which is equal to 33 over 10, or 3.3. All right, now I'm going to substitute this 3.3 for x into this equation here and solve for y. So let's do that. I'm going to do this in green. So now we got y equals -3 times 3.3 plus 6. Y equals -3 times 3.3 is -9.9 plus 6, and that is equal to -3.9. So my coordinates then, I've got one here, which is 0, -5 at this point right here. And we're saying we got another point of intersection right there at where x is 3.3 and y is -3.9. Now, we're going to go to the next slide and we're going to put that through the distance formula to determine the distance between those two parallel lines. All right, so we said that our coordinates of our line that was perpendicular was 0, -5, and 3.3, -3.9. So now we're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared to determine our distance. So we got our square root symbol, and so x2 is 3.3 minus 0 squared plus y2 -3.9 minus -5 squared. We got the square root of that. Of course, this is going to become positive. So now we got the 3.3 squared plus, let's see, positive 5 minus 3.9 is 1.1 squared. And then 3.3 squared is 10.89. And 1.1 squared is 1.21. And so then we're looking at the square root of 10.89 plus 1.21, 12.1. And so let's see, what's the square root of 12.1 approximately? Rounding it to the nearest hundredth, it would be approximately equal to 3.48. All right, that's a lot of fun, isn't it? That's so much fun, and we're going to do another one, except now we got another little wrinkle thrown at us. Well, now let's work on this scenario. We've got a little bit different wrinkle here. We got to find the distance between lines A and B with the equation x plus 3y equals 6 and x plus 3y equals -14. So that is the equations, let's say, for two lines here. And we'll fill something in there in a minute. I want to get these equations in slope-intercept form rather than in standard form like they are right now. And so let's do that. I got x plus 3y equals 6. We're going to get it in slope-intercept form. So now it's 3y equals -x plus 6. And then we're going to divide by 3, where we got -1/3 x plus 2. And we're going to work on the second equation as well, where we got x plus 3y equals -14. 3y equals -x minus 14. And then divide everything by 3. And it's where we got -1/3 x minus 14 over 3. Now, let's see, if I think about that, I got two lines, both of them got negative slope. One of them's got a y-intercept, let's say, up here at 2. And another one's got a y-intercept down here, not quite at -5, somewhere down like that. And I'm trying to find the distance between these two parallel lines. And so I'm going to use this, I'm going to figure what the y-intercept in this equation right here is 2, which means that when x is 0, y is 2. And I'm going to use it as one of the endpoints of my perpendicular line. Now I'm going to write the equation for my perpendicular line. And that would be, let's see, the slope of these two parallel lines is -1/3. So the slope of my perpendicular line is going to be 3. And I'm going to use this point. We're going to do point slope, y minus 2 equals 3x. That means 3 times x minus x1. And x1 is 0. And let's see then, y minus 2 equals 3x. 3 times 0 is just 0, and so y is equal to 3x plus 2. All right, now I'm going to use the system of equations, and I'm going to substitute in this for y into this equation to find where this point of intersection might be. So I think I got enough room here. So we got 3x plus 2 equals -1/3 x minus 14/3. Okay, and let's add 1/3 x to both sides, subtract 2 from both sides. So we'd have 3x plus 1/3 x equals -14/3 minus, let's see, 2 expressed in terms of thirds would be 6/3, -6/3. All right, so 3x plus 1/3 x, so that's 9/3x plus 1/3x. That's going to be 10/3x equals -20/3. And to solve for x, we're going to multiply both sides of this equation by 3/10, which is the same as dividing by 10/3. So now we got -20/3 times 3/10. And those are going to cross product, so I got -2. So x then is -2. And let's substitute that into our first equation. And we're going to do the first equation. Now we'll go back to this one right here, and we're going to solve for y. And I'm going to do that. Now I'm going to do it on this page. So let's see. We would then have y equals -1/3 times -2 minus 14/3. Y equals -2. Let's call it +2. +2/3 minus 14/3. And let's see, 2 minus 14 is -12, so we got y is equal to -12/3, which is equal to -4. And so our second coordinate over here is -4. So we're going to use these two coordinates, 0, 2, and -2, -4, in our distance formula to find the distance between those two parallel lines that we see there with those equations. Let's move. All right, so our two coordinates we said were 0 and 2, and 2, and negative 4, I believe it was. Hopefully I got that right. So let's take the square root of that. So we got x2, which is 2, minus 0 squared, plus negative 4 minus 2 squared. Let's see, and then that gives us 2 squared plus, we got negative 4, negative 2, which is negative 6. That's going to be squared. And that's going to give us 4 plus negative 6 squared is 36. And 4 and 36 is 40, which we could actually reduce to, that's the square root of 4 times the square root of 10, which is equal to 2 square root of 10. Or we could just take the square root of 40, and let's see approximately what that is. Square root of 40 is 6.32 approximately. Woo! Okay, there we go. We got it. All right, got to know the slope. To deal with the line perpendicular, you're going to have the negative reciprocal of the slope of the lines that are parallel. You got to use a system of equation to find the points that would intersect the two parallel lines. You can use the y-intercept for one of those, then you're going to have to use a system of equations to find the second, and then you take those coordinates and put them through the distance formula, and shazam, you're done. You may want to look at this more than once. This is what makes math fun.